You're here because you need to do an in-depth scan data analysis. Connect the scan tool to the vehicle's DCL connector. If the scan tool will not communicate with the vehicle, go to Mill and Scan Data Problems in the main menu. Do not guess at specifications. Look up the vehicle-specific specifications. Do not try to work from memory. Turn the key on with the engine off. Set the scan tool up to read engine data. Compare each data bit to specifications. Engine RPM should be 0. If it isn't, test the PCM. TPS should be within specifications. If it isn't, test the TPS and its circuits. Cold oxygen sensors should show their reference voltage. If the oxygen sensors don't show reference voltage, test the sensor to see if it's shorted. If they are not shorted, go to testing the PCM. As soon as you turn the ignition switch on, the oxygen sensor heater starts heating the oxygen sensor and voltage will decrease. Hot oxygen sensors will not read the reference voltage of 0.4 volts. In fact, it's a good test for heated oxygen sensors. Turn the ignition on and watch the voltage change. Long-term fuel trim should be 0. If long-term fuel trim isn't 0, ignore it for now. Some vehicles won't show 0 until the engine is cranked. Mass airflow should be within specifications. If it isn't, test the MAF and its circuits. MAP should be within specifications. If it isn't, you're going to have to test the MAP and its circuits. Engine temperature should match actual engine temperature. You can use the ECT and compare it to the IAT if the engine has been off for several hours. It's a good indication that they're both working normally if they read the same temperature. A more accurate test is to compare the ECT scan data to the actual temperature of the engine. Measure the engine temperature as close to the ECT as possible. Scan data should be within 10% of the actual temperature. Injector pulse width should be under 55 milliseconds. If injector pulse width is over 55 milliseconds, check for a reprogrammed TSB and follow those instructions. Idle air control will show the amount of bypass air the PCM has set for this engine startup. There are no hard specs of what it should be. IEC counts vary with engine temperature. Compare the EGR position to specifications. If the EGR position voltage is higher than normal, it indicates that the EGR valve is stuck open. Go to EGR testing. System voltage should be 12.6 volts, which shows a fully charged battery. If battery voltage is lower than fully charged, you must find out why. It may be as simple as you've been testing this vehicle with the ignition on for a long period. If you cannot determine the reason, go to Starting and Charging Problems. Now start the engine and let it fully warm up. With the engine running at idle, the data will change to reflect the information. We have stopped the data at one point in time so that we can discuss it. Just like key on, engine off, we'll go through the data and compare it to specifications. Engine RPM should match actual engine speed. If not, go to Ignition and Fuel Control Testing. Compare TPS voltage to specifications. If the voltage is higher than specifications, it is possible that the throttle stop screw has been adjusted and you need to take care of that. If the TPS voltage is not normal, test the TPS and its circuits. And then look at the IEC counts. Compare the counts to specification. If the counts are higher than normal, the PCM is commanding additional bypass air. Check the power steering switch, PSPS switch, the AC switch, and the park neutral switch. Also check the throttle bore for restrictions. You can see this one's carboned up. A dirty throttle bore or a power steering pressure switch, an AC switch, a park neutral switch can cause IAC counts to be higher than normal. A dirty throttle bore indicates that the intake manifold and the back of the intake valves are dirty also. Only cleaning the throttle bore won't fix this problem. Carbon will also build up in the fuel rail and the injectors. If the throttle has been carbon buildup on it, you need to decarbonize the entire engine. Your decarbonization procedure must address all the carbon buildup in the engine. Once you are sure that the throttle isn't dirty or the carbon has been removed, continue with scan data diagnostics. Excessive vacuum leaks can make the engine run so poorly, and the computer will compensate with the IEC, and the IEC counts will be very, very high. Continue comparing the data to specifications. The oxygen sensor should move between 0.1 and 0.9 volt. If not, go to pressure and volume testing. Long-term fuel trim should be within plus or minus 5%. On high mileage vehicles, the spec is plus or minus 10%. If long-term fuel trim isn't within normal specifications, go to pressure and volume testing. The mass airflow should be within specifications. If the mass is higher than normal, check engine RPM. If the engine RPM is higher than normal, diagnose that first. Sticking throttle cables, adjusted throttle stops. If engine RPM is normal, test the MAP sensor and its circuit. If you have difficulty in testing these circuits, you can look on the MPC disk for MAP testing. The MAP sensor should be within specifications. If the MAP is higher than normal, go to engine vacuum testing. If engine vacuum is normal, test the MAP and its circuits. If the MAP voltage is lower than normal, test the voltage reference. Test the MAP sensor voltage reference at the MAP. If reference voltage isn't within specifications, go test the PCM. If reference voltage is within specifications, test the MAP and its circuits. The MAP may be shorted and pulling down the reference. And don't forget that other 3-wire circuits, other 3-wire sensors can pull down voltage reference. Engine temperature should match actual engine temperature. If it doesn't, test the ECT and its circuits. The injector pulse width should match specifications. The injector pulse width may not be within specifications if there is a fuel system problem. If the injector pulse width isn't correct, go to fuel pressure and volume testing. The EGR position should be within specifications. If the EGR position voltage is higher than normal, go to EGR testing. Air inlet temperature should match the actual air inlet temperature. If it doesn't, test the IAT and its circuits. System voltage should match specifications. If not, go to starting and charging system problems. When you find data that doesn't match specifications, you must determine why. Is the condition wrong, as in the fuel is running too rich or too lean, causing the oxygen sensors not to read normally? Or is the engine running too hot or too cold, causing the ECT not to be within specifications? If the sensor is accurate, that is the thing that you have to determine. If not, you must test the sensor and its circuits.